Hello and welcome to this latest video in the OCR GCSE Computer Science series. In this video we're going to be undertaking a walking talking mock of the Sample 1 paper for Unit 2 Algorithms and Programming. Now this is the first and at the time of recording this the only sample paper available for the new GCSE specification, which will be first examined in the summer of 2022. So if you're sitting your OCR GCSE Computer Science GCSE from the summer of 2022 onwards, you'll be undertaking a paper in this style. The Unit 2 papers are a little bit different now in that they are made up of two sections, Section A and Section B. In Section A, you need to answer the questions using OCR reference language. The guide for that is available on the OCR website. In Section B, you can continue to use OCR reference language if you wish, or you can utilize a high-level programming language that you've studied, such as Python or Java. So we're going to go through how we can get full marks on this paper in hopefully the most efficient, time-effective way possible. It'd be really useful if you had a blank copy of the exam in front of you, and what I would suggest is that you attempt each question and then I'll talk you through the answers I will be giving and why. Hopefully you're aware these are the different topics that could come up within the Unit 2 exam. There are 5 sections: algorithms, programming fundamentals, producing robust programs, Boolean logic, and languages and IDEs. So the questions that come up within this sample paper will come from one of those 5 topics, and it will be the same when you sit your real exam in the summer. So let's get going. Like I said, it'd be really useful if you have a blank copy of the paper, and we'll start off with question 1. So I've got a fairly nice first question in that we've got 4 marks available for using some tick boxes, and it says tick 1 box in each row to identify whether the statement refers to a high-level language or a low-level language. So we're looking at that final topic, topic 5, which is types of languages and IDEs, and the first page very much comes from that section. Important, they've said tick 1 box in bold, so sometimes it will say as many boxes, and that means you can tick more than 1, but whenever we see 1, do make sure you just tick 1 box in each row. Absolutely everyone should fill in this question. You've got a 50-50 chance on each row, and it's 1 mark per row. So we've got 4 marks available for not a huge amount of work here. So the first 3 are all high-level languages. They use English-like keywords, they must be translated, and the code written is portable between different processors. Low-level languages is then the final one, and that requires the programmer to understand the processor's registers and structure. Part B then looks at IDEs, and it says a translator is a common tool found in an IDE. Describe 2 other common tools. There are a number here that you could be going for, and the mark scheme for this paper is also available, so you can look those up in more depth if you need to. I would be going for code completion, so when you start typing a word like print, if you type P and R, it might come up in a drop down. If you're creating a program where you're writing print 5,000 times and you only need to write the first 2 letters, that might be really useful. And then a debugger, and a debugger will show you errors in your code a little bit like a spell checker in a Microsoft Word document. So it might underline errors in red and maybe give us some suggestions of where we can make those corrections. So 8 marks available on the first page. You need sort of 8 or 9 marks to get that grade 1. So we should be off to a flying start there with 8 marks on the first page. We've then got a structure diagram, and it says a school uses a mobile phone app to allow parents to book appointments for parents' evenings. They've given us a basic structure diagram and then a number of tasks, and we need to identify which of those tasks we're going to place in which of the boxes. Now again, it says in bold, write 1 letter, and again, you absolutely should be making an educated guess if you're not 100% sure on the answers. So we've got 4 marks available. We need to pick 4 of those letters and decide which is going to go in which box. C goes in the first sort of level, so when people log in, they've got the login option, they've got the manage appointments option, and then they've got their update personal details section. Manage appointments is going to break down into booking a new appointment and viewing appointments, and view appointments is going to break down to D and F. Now, it doesn't matter which way round you put them, so if you put F first and then D, that's absolutely fine. D is view appointments on screen, F is print out a paper copy of appointments. This is another example of a question that is a little bit of common sense. You should be able to attempt this question having never studied computer science before. And again, it's getting us 4 marks, which is a fairly decent number when the entire paper is only out of 80. It then says, at the parents' evening, each parent can book up to 5 appointments with teachers. Appointments for one student are stored in a one-dimensional array with the identifier appointments. So when we think about an array, a one-dimensional array, we just mean a list of values, A, B, C, D. In the array, each element is either the name of the teacher or an empty string where no appointment has been made. For example, we might have Miss E, then a blank, then Mr. C, then Mr. B, and then another blank. The following code shows an algorithm to count up how many empty slots remain in the array. It's given us some OCR reference language, and that might be useful in later questions. So if you had a mind blank on how to do a for loop, for example, that question might help us. And if we weren't quite sure how we could do an if statement, again, this question shows us how to do both of those things. So bear those in mind as you move on through the paper. But it does say there are some errors in this code. It first of all wants to know what a logic error is, and then it wants us to identify the 2 logic errors. So we can have a logic error and we can have a syntax error. A syntax error is where we spell our code incorrectly, or we write some sort of command word that doesn't exist. A logic error is where the code would run, but it would produce the wrong output. Now normally that's something like swapping a greater than or a less than around, or putting something like a variable name in speech marks so it says the word rather than outputting the value from that variable. It's then asking us to identify the 2 errors in this program, and I do there. We've got line 2, which is setting empty to 0. That should not be inside the for loop. So empty equals 0 shouldn't be indented, and it should be line 1. So we set empty to 0 at the start because we assume there are no empty slots. Because empty is inside the for loop, the code's not going to work quite as we expect. We've also got an issue on line 7. We're printing empty. And empty is the name of a variable, and because it's a variable name, it shouldn't be going in speech marks. What line 7 will actually do is just print the word empty. It's not going to print the value that's held within the empty variable. We're then told that each teacher has the assessment grades for each student and that they're stored in numeric order. So whenever we've shown a list that's in numeric order, we're thinking of something to do with a binary search. We're then asked to show these steps that a binary search would take to check whether the student has achieved a grade 7 in any assessments. Your answer must refer to the grades provided, so you've got to be specific to this list. And this is the mistake that students tend to make in this question, and a question like this has come up in one of the previous past papers as well. You must be very specific to this list. How would a binary search work on this list? We know we're giving 4 points here because we've got 4 marks to make. Whenever I've got a question where it's sort of not an essay question and I know I need to make a certain number of points, I like to my answers. And you'll see here I've done a couple more than 4 because there are more than 4 steps available. We need to find the middle value, which in this list is 5, because again it's told us to be specific to the grades provided. We want to compare 7, which is what we're looking for, to 5, because 5 is the middle value. And as 7 is larger, we're going to discard 2 to 5. We're going to discard the bottom half of the list, including the numbers 2 and 5. We're then going to find the new middle value. So our new list is 6, 7, and 8. The middle value there is 7. We're going to compare 7 to 7, and yes, we have found it. So like I say, I think that's a really important sort of strategy point when you're undertaking these sorts of questions, is to bullet point your points that you're making and be really clear to the examiner that you are making 4 very distinct and different points. It then asks us to explain how a binary search would determine that value does not appear in a given array or list. So how would the binary search work out, okay, this doesn't exist? Answer is, once the list gets down to only one value, e.g. we've halved the list and then halved it again and halved it again to a point where we've only got one number left, if the value isn't that number, well, it can't appear in the list. So in short, only once the list gets down to one value, check that value, and if it's not that, it can't exist. Finally, give one advantage of a binary search over a linear search. That one is always going to be that it is faster. That is the big advantage of a binary search. It's going to be the speed, and it's always going to be that it's faster. If we were asked that question the other way round, why is a linear search better? It would be because it doesn't require it to be in numeric order. Getting towards the end of sort of section A of the paper now. Question 3, we've got a cinema using the following criteria to decide if a customer is allowed to see a film that has a 15 rating. Customers have to be 15 years of age or older to see the film. They also need to have either a ticket or have the money to buy a ticket. It's asking us then to draw this system using logic gates. So we've got A, input A, which is whether the customer is over 15. We've got input B, which is whether the customer has a ticket, and we've got C, the customer has the money to buy a ticket. This is really then about, can you remember the shapes of the different gates? So we need an OR gate here, and we need an AND gate, okay, to add up these three criteria. So we're going to have B and C going into an OR gate. That means that the customer has got the money to buy a ticket, or they have a ticket already. We're then going to put that output through an AND gate with A, which is the customer 15 years of age or over, and that's going to give our output, and we normally label our output Q, but you don't necessarily need that part in there. 2 marks there for are you getting your right shapes and are you getting your right sort of layout of your logic gates. We're then asked to complete the algorithm, one of our first sort of OCR reference language questions, to output whether the customer is allowed to see the film or not. They've done the input bits for us, so we now know we need to be looking at an if statement. Now, we've seen earlier on in this paper an if statement in action, so if you were really struggling with how an if statement was done, it'd be worth looking back on that earlier question where we were given some code and trying to utilize that. But in short, we need if A and then in brackets B or C equals true, we're going to print allowed, else we're going to print not allowed. And you can add that end if there that OCR seem to like within their reference language. 3 marks available. You know, have we got our basic if statement? Does it work? And are we giving relevant output messages from the if and the else element there? Part C, the cinema has 3 screens, red, black and yellow. Write the code using the function free seats to find the number of seats available in screen red and assign this to the variable with identify red seats. This is a question you're going to either sort of remember how to do or not. It's going to be red seats equals free seats and red in brackets. So we've got a function called free seats. We're passing the parameter of red, and we're setting that answer or what's returned from the function to red seats. Question 4, a car dealership uses a computer system to record details of the cars that they have for sale. Each car has a make, model, age and number of miles that it's been driven. Each car has a star rating of 1 to 5 based on the age of the car, the number of miles that have been driven. This rating is recorded in the computer system. Define the term abstraction. Well, abstraction is removing detail not required so that we can focus on the information that is going to be important to us. You'll be able to think of lots of examples of that in computer games where the developer has ignored things that happen in the real world to make the game either more fun or easier to program. We're then being asked to give one example of how abstraction has been used in the design of this star rating system. So what are we ignoring about the cars that isn't included? Loads of examples here, so I've gone with ignore factors such as the colour. Like I say, there are loads of examples there you could pick from. Pick something sensible about the car that isn't being input specifically into the star rating. We're then asked a little bit around defensive design, and it's asking us to explain how authentication could be used as part of the defensive design of this computer system. And again, I need to make 2 points. It's got 2 marks as this. So this is another prime example of a question where I would be using bullet points to really show off my 2 different. We would use passwords. That's my sort of point. What impact is that going to have? Well, that would ensure that only certain users can make changes to the program. Again, a prime example of a question where I really would focus in on bullet points to make sure my 2 points are really clear and concise. Part B. The car dealership only sells cars that have fewer than 10,000 miles and are 5 years old or less. Write an algorithm that will ask the user to enter the number of miles and the age of the car. Will validate the user input that only sensible values can be given, and output true if valid data has been entered. They've got 5 marks here, so this is quite a big OCR reference language question. They've also been really nice and they've bullet pointed exactly what we should do. The issue students have here is they look at the question and think, oh, I can't do that, so they don't write anything at all. The first bullet point, for example, is really easy. Ask the user to enter the number of miles and the age of the car. So we're going to get at least 1 of our 5 marks just for doing that. So if you can't do the whole question, make sure you do attempt at least the basis of the earlier bullet point. So I've got miles equals input and enter miles, and then I've done the same for age. So I'm going to get 1 out of 5 just for doing that. I'm going to assume that valid is set to true. I'm going to set it at true to start with. And then I'm going to say if miles is greater than 10,000 or miles is less than 0, valid equals false. So if the miles are outside of the appropriate range, say that valid is false. Then going to do exactly the same for age. Else if age greater than 5 or less than 0, valid equals false again. End if, and at the end I'm going to print out my valid to show whether it was true or false. The validation routine for part B must be tested with normal, erroneous and boundary test data. Identify suitable test data for each type of test. So it's asking me to come up with some normal, some erroneous and some boundary test data for those. A little bit of leeway in some of these answers, but I want some miles that are right in the middle of what's acceptable. I want some miles that are outside of what's acceptable, and I want some that are right on the boundary, and again for age. So miles we know has got to be less than 10,000, so 7,000 is kind of in the middle, 12,000 is definitely above that, and 10,000 is right on the edge. And then the same for age. I've gone for 3, 7 and 5. You've got a little bit of leeway within that answer set. Finally, identify when iterative testing is performed. Iterative testing is performed during development. That's a question where we don't need to write loads. It's testing that's ongoing as we work through the program. We've then got the first of our sort of really big questions. You'll always have a question or 2 that take up the entire page on the exam. In Unit 1, there'll be essay questions. In Unit 2, there'll be algorithms. The car dealership sells electric cars which require charging before they can be driven. Charging the battery by 1% takes 10 minutes. For example, if the battery has 80% charge, it would take 200 minutes or 3 hours and 20 minutes to charge. Write an algorithm that asks the current percentage, outputs full if it's at 100%, calculates how long this battery would take to charge, and outputs that in hours and minutes. Now this is another prime example of a question that you have got to give a go. Just because you can't do the full answer, you should better do the first and probably the second bullet point, even if you've just studied computer science at a fairly basic level. What you'll also notice from my we don't anywhere near need to fill up the space. This is not a full page answer. So don't sort of look at the page, the big page available to put your answer in and think, oh no, I definitely can't do this. So charge equals input enter charge, and then if charge equals 100, print full. So if the charge is at 100%, print full. We're going to get 2 out of 6 just for doing that first section. We've then got our else statement where we're looking at time, and we've got time equals 100. So we're assuming that we've started at 100% minus the charge times by 10. So we're doing the basic calculation there that 1% takes 10 minutes. I then need to work out hours and minutes, and this is where mod and div come into this answer. So hours equals time div 60. That is saying how many times does 60 go into time as a full number. So how many full hours have I got? Mod then does exactly that, but works out the remainder. So mod is really useful for working out the number of minutes. Finally, we need to print out hours and minutes with some kind of apostrophe or dash in between, and you might give a nice message there to say this is the number of hours and this is the number of minutes. Now again, that's a question you've got to give a go. Don't look at that page and think, wow, it's a full page, I definitely can't do that. I think everyone would be capable of getting 3 out of 6 on that question, if not a little bit more. We've now moved on to part B, and it says here we advise you to spend at least 40 minutes on this section. For part B, you're going to be getting more algorithm questions, so nearly every question is going to ask you to write some code. And you can answer there in OCR reference language or something like Python or Java. Now, there are 2 options. Absolutely nail OCR reference language, because that will appear in part A, so you're going to need it. Or it might be that actually you've done okay on that, but you do feel more comfortable in something like Python, and therefore you want to answer the rest of the questions in Python. Either way, we've got a nice first question because we've got another set of tick boxes, and it's asking us about SQL. So it's giving us a specific high-level programming language. It's asking us to work out the query for this example. Answers for that one are select item code, comma, item name, from table stock, where price greater than or equal to 60. So a fairly nice opening question to part B. We've then got a flowchart. We're given some data and it's asking us to work out what we'd expect the output to be. So in short, we need to, for the first part, put 50 in and follow on through the flow diagram. So is the price greater than 200? Well, no, 50 is not. Is the price greater than 100? Well, no, 50 is not. So we output price. Well, price was 50. We've done nothing to it, so it must still be 50. We need to do that for the other questions. So 100, 150, 200, and 250. So this is a basic question, just some very, very basic maths, and just can you follow through that flow diagram with the numbers given to you in the table. We've then got to rewrite the algorithm from part B using either OCR reference language or a high-level programming language of our choice. Sticking with OCR reference language, I'm entering price. If price greater than 200, price equals price minus 40. Else if price greater than 100, price equals price minus 20, and then print price. Again, not a hugely difficult question there for the 6 marks that are available. Particularly if you've used Python a lot in your school, you should be able to have a good go at that question, particularly when we've been given the flow diagram on the previous page. An item is classified as in demand if OCR Tech have between 5 and 25 inclusive in stock. So that means we include the numbers 5 and 25. A program is written that allows the user to input the current stock level and output whether the item is in demand or not. The program contains syntax and logic errors, so there are some issues with this code. Rewrite the program basically so that it isn't broken and it does work. So for example, our prints, print not in demand, print in demand, should definitely be in speech marks, shouldn't they? And there are a few other issues, particularly with our if statement. So the big changes are on line 2. So if stock level, in that stock level should be written in the second part. It should be an and, not an or. And the print statement should be in speech marks. Again, 5 marks available here for basically rewriting their code and identifying 2 or 3 potential problems. 5 marks could be the difference between a grade for you. So really worth having a go at these sorts of questions. We've then got a fill in the blank question where we're given some OCR reference language and told about a program that's using a 2D array. Now I think these are amongst the hardest questions. It's not our code, it's code someone else has written, and the general use of 2D arrays can be fairly complicated. So we've got a for loop. We're going from x0 to something. We've got an if statement where we're checking if discount x0 equals something. We're setting new price, and we've got a blank towards the end. Now it's a function, so we know a function returns a value, so we know the bottom one is going to be returning something. But like I say, some of these other sections are a little bit more. So we've got for x equals 0 to size. So we've worked out size on the line above, and that's length of the list minus 1. So that's straightforward. If discount x0 equals code, so that's the code that we've passed into this function as a parameter. New price equals price, which kind of makes sense. It's the previous price minus the discount x, comma 1. End if, and at the bottom we're going to be returning price, new price, sorry. Like I say, a tough question there. That might be one you do struggle to gain full marks on, mainly because the code is written initially by someone else. But there are a couple of obvious ones. So for x equals 0 to size, for example, should be achievable. We're then asked to identify two variables used within this function. Now we need to be careful here. Price and code are both parameters, not variables. So they're passed into the function from another section of code. So we're looking for what are our variables that aren't price and code. What are used? Well, we've got size and we've got new price. Either of those would be fine for that question. We're then on to the final question of this exam. This will normally be a big sort of page-long question. As we said before, it will be an essay for Unit 1 or a reference language question for Unit 2. And it's asking us to write a program that asks the user for an item price and a discount code, uses the function that we were given on the previous page to calculate the price, represents bullet points number 1 and 2 until a price of 0 is entered. So we're thinking some kind of loop there, probably a while loop, and outputs the total cost once we are done. Now, the last question will always be a challenge. This is always going to be a tough question, but it's also almost always going to be 6, 7, or 8 marks. Again, this is a question where they've given you a full page and you really don't need a full page to answer. That, I think, is the simplest and quickest way of answering that question. Set total to 0 and set price to 1. While price doesn't equal 0. So I've set price to 1 so that I enter my while loop the first time round. It said in one of the bullet points there, repeat while price doesn't equal 0. So we know we're going to need a while loop. Price equals input, code equals input. And then the tough part, I suppose, is the penultimate line. Total equals total minus check discount price code. So we're using that function from the previous page and we're passing in our price and our code variables. Now, because it's a function, you can call price and code whatever you want as long as you call them the same thing on the previous lines where it says price equals and code equals. Finally, we're going to print total. Now, this is another prime example of a question that you really need to give a go. You should be able to attempt this question and get maybe 4 out of 6, even if you don't think you'd be able to get full marks on it. However, that is a model answer and the one that I think is the quickest way of gaining full marks on that final question. So that is, at the moment, the only sample paper available for the new Unit 2 exam. As I said at the start, from 2022 onwards, your exam will be split into Section A and B. There are other sample papers from the old specification available, and I've done some walking talking mocks of those. They don't, however, use Section A and Section B in quite the same way, so it's very worth having a good go through this paper a couple of times before your real exam. Thank you very much for watching. If you do have any questions, please post those either onto Google Classroom or into the comments section below. Thank you very much.